plane operates on only 3 engines. Dangerous incident.
Warning.
Find out what happened to the plane. The incident occurred immediately after takeoff. The flight left the runway like any other, smooth and powerful, typical of a Boeing 747 familiar with the crowded skies of Los Angeles. But just seconds after the landing gear left the ground, everything shifted in a way that any veteran professional would understand. Those things that no one wants but sometimes still happen. From the left wing, a sharp pop rang out, loud enough to break the steady rhythm of the takeoff. That was not the sound of metal or a collision, but a clear signal that engine number 2 was having trouble with its airflow. The aircraft felt a slight vibration, as if the 747 had just stepped on a ripple in the air. To a layperson, the sensation might have been fleeting, but to those with experience, it was a sign of a disturbance inside the combustion chamber, an airflow misalignment, a reaction out of cycle. Small flashes appeared at the engine's rim, as if heat was being pushed back out instead of being contained and operating within the correct rotation. There was no chaotic scene, no panic. It was just a 747 trying to maintain stability in the first few seconds of the journey, while its systems signaled that something abnormal had just begun. The flight crew felt it clearly through a small change in thrust, slight but impossible to ignore. The airflow on the left side was partially lost, and the giant aircraft immediately showed this by banking insignificantly to one side. Such situations happen fast, cleanly, and without warning. That is why the aviation industry always emphasizes every detail, because just a small malfunction right after takeoff is enough to open a complex chain of decisions lasting the entire flight. At that moment, the flight crew understood that this journey would no longer be a simple flight. It had become a real test of technique, experience, and absolute precision in every subsequent choice. Engine number 2 surged and shut down completely. As soon as the abnormal signal appeared on the left engine, the control panel in front of the crew began to light up with numbers they did not want to see. The temperature in the combustion chamber rose quickly, like someone had just turned an oven up too high. That is a familiar sign of a phenomenon technicians call a surge. The airflow no longer moves in the right direction, gets blocked, and then reverses, creating violent sneezes from inside the engine. To an outsider, it was just a few small flashes. But in the profession, it was a clear warning that the engine was losing its rhythm and was no longer strong enough to contribute to the aircraft's thrust. When the temperature needle began to climb to an intolerable level, the crew moved the engine's throttle to the lowest setting. This is a mandatory step to prevent the engine from overloading. But even when reducing thrust, signs of the misalignment still appeared. Small jolts continued to show up in the data, confirming that inside the engine, the airflow was rotating in an unwanted way. Just seconds later, they chose the final option: cut the fuel. And as soon as the fuel flow stopped, engine number 2 stopped working completely. The 747 lost a portion of its thrust, but maintained its flight path thanks to the 3 remaining engines. With the mechanics of this aircraft, losing one engine is not something that requires stopping the trip immediately. But losing it right after takeoff, when the plane is still heavy, climbing, and without much room to maneuver, is a completely different story. This is the type of incident that any maintenance engineer understands can stem from a variety of factors. Turbulent air, a small object ingested into the intake, or simply bad timing combined with unfavorable aerodynamic conditions. When the engine stopped, the 747 was not like a wounded bird, but clearly, it was no longer in a perfect state. The crew realized they were facing a new problem: keeping the plane stable, accurately assessing the situation, and preparing for a more complex chain of decisions in the coming minutes. This is when professional experience and precision become the deciding factors, because from now on, every choice must be based on data, procedures, and deep understanding of how a 747 reacts when only 3 engines are accompanying it. Standard initial handling procedure. At an altitude of 5,000 feet, the cockpit was immersed in a silence as still as a sheep, the kind of silence any veteran pilot recognizes immediately. Something is wrong. One engine was off, and the other was working alone amidst the dense air near the ground. No one spoke unnecessary words. They just focused on the checklist, step by step, exactly as drilled over years of flying. The captain turned on continuous ignition, a familiar procedure designed to spark continuously, hoping to bring hot airflow back into the combustion chamber. They tried restarting the engine multiple times, each time following the correct order. Open fuel valve, observe rotation speed, monitor temperature, and listen for any sign that the engine was catching again. But every indicator coldly refused. The numbers lay dormant without any response. Not letting the situation drift too far, they declared pan-pan to air traffic control. This is not the highest level of alarm, but enough to announce that they needed clean airspace, priority routing, and maximum support. The control tower answered immediately, switching them to a dedicated frequency and requesting a further technical report. I in the cockpit. The two pilots continued to review the entire system, from fuel pressure, compressed airflow, to related sensors. Each item was read, cross-checked, then crossed off. There was no sign of fire, no abnormal vibration, nor any warning other than the fact that the engine simply refused to wake up. With over 3 decades in aviation journalism, I have seen many incidents start exactly like that. No noise, no drama, just numbers refusing to move in the normal way. And when the numbers stand still, everything else is forced to operate perfectly. This was just the opening step for a life-or-death decision chain that the crew had to make in the next few minutes that would shape the entire story of this flight. Turn back or move forward.
Controls checked.
When the incident became clear and engine number 2 could not be recovered, a cold question was posed. Should they return to Los Angeles Airport or continue the long journey? On the crew spreadsheet, the figure of 119 tons of fuel on the aircraft was like a heavy weight pressing down on the decision. This amount of fuel was too large to allow a safe landing immediately without reducing the load. Turning back was not as simple as making a U-turn in a car. To reduce weight, the aircraft would have to perform a fuel dump operation, an action that takes time up to 40 minutes while also costing a significant amount of money and impacting the environment. This is time during which the Boeing 747 is gradually losing stability in the air with a paralyzed engine. The flight computer was set to calculate the remaining range precisely based on current fuel and weight. The numbers showed that, even with one engine inoperative, the plane could still continue the journey to London, the final destination, with fuel reserves meeting safety standards according to regulations. This was a calm but high-pressure situation. The choice between immediate safety nearby and long-term economic calculation presented the crew with a difficult problem. Trade the wait time of dumping fuel to return, or maximize the existing fuel to cover the long distance, even though potential risks remained. In those moments, every number, every calculation is weighed and measured not just by data but by procedure, by experience, and by principles engraved during hours of training. That is why the decision is not based on emotion but must be the product of a rigorous and high-pressure logic chain, where every minute can determine the fate of the flight. Risk assessment on the long journey with remaining 3 engines. As the Boeing 747 continued its journey with one engine completely shut down, the pilot was forced to face the unavoidable truth. Flying transcontinental now relied only on 3 healthy engines. This was not an ideal scenario, but also not something unprecedented in aviation history. It all lay in correctly assessing the level of risk and preparing for every situation that might arise. Engine number 2, though stopped, was still spinning thanks to the airflow, a state called windmilling, proving it was not completely destroyed and there was no sign of fire spreading. This was a technical bright spot, showing the engine system was not damaged enough to affect the aircraft's main structure. This helped limit shaking and kept the plane more stable in the air. Additionally, the crew considered the possibility that a 3rd engine might encounter trouble, a risk that always exists in every flight, however rare. But they were not flying in a wasteland. The network of backup airports across the US provided many emergency options, where the plane could land quickly if further malfunctions occurred. This created an additional safety layer in an extreme situation. Maintaining the flight with 3 engines was not just about technical control but a problem of risk management. The crew had to balance the aircraft's ability to operate stably, the remaining distance, and surrounding rescue resources to decide on the safest option that still ensured flight efficiency. In a world with no room for error, this was a moment of sharp calculations, where every number and piece of technical data became the basis for hard decisions in the vast sky. The captain's decision under the spotlight, when the plane fell into an abnormal situation, The voice from the British Airways Operations Center at Heathrow was not merely a recommendation. They clearly emphasized the priority of maintaining the journey, as long as the aircraft still ensured flight safety. This was a short but heavy message, placing the entire burden on the crew's shoulders, especially the captain, the final decision maker in the aviation industry. A small incident can drag along a series of consequences regarding finance and reputation. Turning back, even if it was the safest choice in the eyes of many, meant fuel costs burned in vain, loss of time, broken connecting flight plans, and significant operational troubles. The airline could not stand outside this game. They needed the flight to continue to keep the schedule, ensuring revenue flow and reputation remained unaffected. Behind the advice to continue flying if possible was an invisible pressure, yet powerful like an undercurrent flowing deep beneath the surface. The captain, though understanding the technical status best, still had to weigh consequences beyond the technical aspect, from financial pressure, operational responsibility, to the airline's image in the eyes of the public and investors. The decision at this time was not simply a choice based on technique, but a gamble with many interwoven factors between safety and profit, between responsibility and risk. The captain stood in the middle of this vortex, having to choose a path based not only on data but also on a series of considerations that only those seasoned in the industry could understand in their importance and depth. In the aviation world, that pressure cannot be measured by numbers or words, but it is always present, like a ghost accompanying every decision in the vast sky. When every minute is a harsh test. After more than 2 tense hours in the air, the Boeing 747 began to show signs of stability at an altitude of 27,000 feet, flying slower and lower than usual. All technical indicators remained within the control zone, with no new danger signals arising. That was not absolute peace of mind, but a continuous verification step on a thin line between normal and potential danger. The crew canceled the pan-pan alert, a sign that the emergency status had dropped to a manageable level. However, this did not mean everything was absolutely safe. They continued the long journey across the US with high vigilance, preparing for the next big decision as they approached the point of crossing the Atlantic Ocean, an unpredictable space with few backup options. Upon reaching the United Kingdom, the crew encountered difficulties in balancing the remaining fuel. The captain subsequently declared an emergency and landed safely at Manchester Airport. The decision to fly on was not made on emotion, but based on data and thorough assessment. Maintaining a lower altitude helped reduce pressure on the wounded aircraft, while also being a way to save fuel and control speed to ensure the best handling capability in an imperfect condition. That it was a battle of patience against the clock and every system on the plane. As every minute passed, the Boeing 747 silently moved forward, both a challenge and a testament to the determination to maintain the flight in imperfect conditions, before entering the decisive phase that could affect lives and the airline's reputation. The crew's decision at this moment was not just a technical choice, but a story of endurance and control capability when every road could lead to unforeseen consequences.